Section 5.7 is about formulas and applications, and the objective is to solve a formula for a letter. And to solve a rational formula for a given letter, identify the letter and then multiply on both sides to clear fractions or decimals if that is needed. Then multiply if necessary to remove parentheses, and then get all terms with the letter to be solved for on one side of the equation and all other terms on the other side, using the addition principle, and then factor out the letter if it appears in more than one term. And number 5, solve for the letter in question using the multiplication principle of equality. So it's very simple, and we're going to do some examples here. The first one is the so-called combined gas law. So this formula P times V divided by T equals K relates the pressure P, the volume V, and the temperature T of a gas. Solves the formula for T. So in other words, we want to know what T is equal to. That is also the common denominator, so we multiply both sides of the equation by T, and so it's going to look like this. PV divided by T equals K. So we multiply both sides by T, which now means we can cancel the T's on the left side. So we now have the equation PV equals K times T, and we want to isolate T, so we divide both sides by K. So we can cancel the K's here, so T is equal to PV divided by K. PV divided by K. And by the way, that's a lower case letter K. So when it comes to formulas, the case of the letter has a lot to do with the formula, so do not change from uppercase to lowercase and vice versa. Leave the letters the way they are. And the next example is the so-called Doppler effect that's used to determine the frequency f of a sound that is moving at a velocity v towards a listener who hears the sound. As frequency g. Here S is the speed of sound in a particular medium. Solve the formula for S. So that's the letter S here in the numerator and the letter S in the denominator. And by the way, the Doppler effect is used also for radar, like speed guns and all of that. They use that. And before I forget, I want to point out, be sure to study all the examples in the book. They have a lot of examples how to solve for a particular letter in a formula, so make sure you do that. Okay, so looking at this formula for f, so we need to multiply both sides by the denominator, s plus v. So then, by doing that, on the left side, then f times s plus v equals s times g, because when we multiply by s plus v on the right side, then the denominator cancels. So now we use the distributive property, and then fs plus fv equals sg. So now we need to get the terms with the letter s on one side and the others on the other side. So in this case, we subtract sg on both sides. It gives us an fs minus sg plus fv equals sg minus sg, or 0. Then we factor out the s in this expression here. So s times f minus g equals minus fv. And so now we can divide both sides by f minus g, by this expression in parentheses. So we divide both sides by f minus g. So s times f minus g divided by f minus g equals minus f v divided by f minus g. And so on the left side, the f minus g's cancel. And so s is equal to minus fv divided by f minus g. Now, it's not very nice to have a minus sign here in the numerator. So what we can do is we multiply numerator and denominator by minus 1. So then that becomes a positive f times v. And in the denominator, I get minus 1 times minus g is g. And minus 1 times f is minus f. So that's what the expression is like for the letter S. Fv minus gf. Next is a guided solution, and it solves the formula I equals pt divided by m plus p times n for the letter n. So we want to know what n is equal to. So the first thing is we multiply both sides by the denominator m plus pn. So m plus pn equals p times t because the denominators cancel out. Then we use the distributive property im plus I times p times n equals pt. Then we subtract im on both sides because we're solving for n, so we want to have only one term with the letter n on one side. So it's pt minus im. And now we divide both sides by ip to isolate n. So divided by ip. And that's, now we solved the formula for the letter n, for the variable n. So that's the final answer here. The next example is a work formula, which we looked at just a little while ago. And that is when we have the, A and B do the work, and what is the work together? So T divided by A plus T divided by B equals 1 job. And so individual times the A and B solves the formula for T. So we want to know what T is. So AB is, of course, the LCD here, A times B. So we multiply both sides of the equation by AB. So the LCD is AB. So then AB times T value divided by A plus T divided by B equals AB times 1. So then we use the distributive property. This becomes AB times T divided by A. Plus AB times T divided by B equals AB. Now the A's cancel and the B's cancel. So now we have BT plus AT on the left side equals AB. Now we factor out the T. So T times B plus A equals AB. Now we divide both sides by B plus A to isolate T. So then T is equal to A times B divided by B plus A. So here we divided both sides by the expression b plus a to isolate t, and then we divided on the right side by b plus a, and so the final answer is t equals ab divided by b plus a. Or you could write it as ab divided by a plus b. Either way. The last example is solving S equals 2 pi r h plus 2 pi r squared for h. That, by the way, is a formula for the surface area of a cylinder. That's the two ends, and this is the side of the cylinder. And so we are solving for h. So in other words, we want to subtract this term. Well, we can subtract 2 pi r squared on both sides. So then we get S minus 2 pi r squared, that's a capital S, that's 2 pi r squared equals 2 pi r h. And so to isolate h now, we divide both sides by 2 pi r, 2 pi r. So the 2 pi r's cancel. So h is equal to S minus 2 pi r squared divided by 2 pi r. And no, you cannot cancel anything of the pi or the r against this term here, because it is a term of the sum, and therefore you cannot cancel anything here. This is the final answer for h. This concludes section 2.7.